coupon frequency. And let's add one more. Behind that plus sign, there's the macro that adds the row to the table. And years to maturity. So I'm going to enter 1,000 here. Of course, I'm anal about this. That's a dollar number. If I was teaching this in Europe, I would have used the euro sign. Coupon rate is, I'm going to have 12.5% just for the hell of it. I like putting some additional stuff, additional two, let's make this 10 years, okay? Now, this green cell here is the cell where I write a formula to calculate the value of the bond given those inputs. I can write the whole thing in one shot, but I like making things a little bit easier for myself. So let's see. Come on. Not coupon, coupon. Dollar coupon amount. I'm going to have one more period interest rate. I don't need that note. Number of coupons. Well, that's easy to do. Years to maturity times coupon frequency. Right, I'm going to make this a little bit easier. This is D9 times D8. Coupon amount, face value, which is D5, times coupon rate, which is D6, divided by coupon frequency, which is D8. We'll deal with the formatting. Period interest rate, yield to maturity, which is D7, divided by coupon frequency, D8. Okay. I'm going to make these all red. That's going to be a dollar term. That's going to be percentage. And that's just going to be a regular number. So if this was a 5-year bond, I have 10 of those. Or if this was 5-year bond, quarterly, so on and so forth, right? These are my intermediate calculations because there is an Excel formula that can easily calculate present value of an annuity with a balloon payment. That's what this bond is. And the name of that function is PV, short for present value. I'm going to hit Control A so that it gives me my function helpers. What is my rate? The rate is the period rate. Remember, that's yield to maturity is an annual rate, and period rate is calculated separately. How many periods are there? Number of coupons. What is the payment? Coupon payment. And that's my coupon amount. And FB is technically for final value, but in this case, that's also face value. That's D5. Ignore the last argument, that's optional. And unless you're dealing with annuity in arrears, which means payments are made at the beginning of a period, but all bond payments are made at the end of each period. Hit OK. It said negative because whoever wrote this function for Microsoft must have been an accountant. It views things as debits and credits. Well, if you get payments, coupon and otherwise, what you're paying for it is the present value. So one of them is a credit, the other is a debit. That's why I put a negative sign in front. Apparently I have not. Of course, I'm going to make this all dollars. This right-hand value is the difference between a target value and the value of the left-hand side formula. That's going to come in handy for later purposes. But right now, I have means to calculate value of any bond. You can be, let me also change this. If this thing is greater than, greater than 0, call it solver mode. Otherwise, call it setup mode. Now, if it's red light, it's going to be in setup mode. If it's green light, which you can change by simply double clicking on that, right? You should use setup mode literally when you're setting up the problem. Or if all you want is calculate the value of the bond given all the inputs. So if I want to do a 0 coupon bond, semi-annual compounding, 30 years. For example, this bond would make no payments for 30 years, except at the end of the 30-year period, it's going to give you $1,000. And if the proper yield to maturity is 12.5%, you would pay only $26.32 for this. If yield to maturity is about 4, it's about $300. Okay? So given the inputs, I can make all the calculations I need. I'm going to highlight what else we can do with it. Sometimes we know the value of the bond, but we want to figure out one of the inputs given that value. The most famous one is the yield to maturity. And let's make this 12% bond, which means it's going to make $60 payments for 60 periods. Then it's going to make another what you want to call $1,000 payments. Since the coupon rate is a lot higher than yield to maturity, you have to pay a lot more for this bond. Suppose I knew that value of this bond is $2,000. What would be the implied yield to maturity given everything else? Remember, years to maturity, coupon rates, face value are all fixed, and coupon frequency are fixed at the time of the issue. So I'm going to go here, pick my unknown yield to maturity. I'm going to enter target value of $2,000. Let's make that as well. Now, as soon as I convert that to green light, it does two things. One, it highlights the unknown that you're solving for. Suddenly that becomes pink background. And it also solves value of that. That's going to give you a price of 2,000. And when you're in green mode, if you change any one of the inputs, it's going to automatically solve it. For example, if this was a 5% coupon rate, that would imply a yield to maturity of 105, right? Or 108. We'll continue with this on Monday. We'll expand it a little bit more with different kinds of inputs. And we will also talk about the nature of the interest rate risk. If, for example, let me go back to green. Suppose the interest rates were 4, this is 1173. If they went up to 5, price of the bond declined quite a bit. And that has to do with the length of the bond and stuff like that. We'll talk about those. I'll post your homework tonight after I go home from teaching, and I'll see you guys Monday.